Okay, welcome back. So we're going to look at part 2 now of section 5.2. So we're going to start back up with this remainder theorem. So the remainder theorem of polynomials says that if f of x is a polynomial and you divide it by x minus c, so kind of what we just ended up doing on the end of the last part, then the remainder is f of c. Okay, so that's the function value. So you can find the function value at a point, and if you get that function value, that would be the same as the remainder, which remember was the number that we got at the end. So we're just a different way to find the remainder. And it says if the remainder is 0, then x minus c is a factor. Okay, because remember, if your remainder is 0, like this one was, that meant that that x plus 10 went in there evenly, so that means it's a factor. If you get a remainder, then that means that is not a factor. And remember, these are factors. X plus 10 is a factor. Negative 10, that's the 0, right? So remember, those are kind of the same thing. It's just the way you're looking at it differently. All right, so example 7 says, if f of x equals 2x cubed plus 11x squared minus 7x minus 6, use the remainder theorem to evaluate the following. Use the remainder theorem. Okay, well, the remainder theorem says it's f of c. Okay, so if I want to evaluate then I can think about it as dividing by x minus c. So let's do it, let's kind of look at it both ways. So if 2 is what you're looking at, I could, and you can pick whichever way you like, so let's look at this and you decide. So if I were to divide this, I would get 2, 11, negative 7, negative 6. Bring down the 2 and do synthetic division. So I would do 2 times 2, which is 4. I would add that, 15. 2 times 15 is 30. Add that, 23. 23 times 2, that's 46. And I would add that. So there's my remainder, which means this is 40. That's the function value. Okay, so that's what that theorem says. So do you think that's easier than just plugging in 2 here? You have a calculator, so I don't know, but you could just do 2 times 2 cubed plus 11 times 2 squared minus 7 times 2 minus 6. If you were to work that out, guess what? That would equal 40. Okay, so if I didn't have a calculator, this is probably easier. If you have a calculator and you want to plug that in, so even though it says use the remainder theorem to find that, nobody says you have to. This is just showing you that that's another way to do it. Okay, so for me, if I don't want to grab my calculator, this took me less time probably than to do 2 cubed is 8, 8 times 2 is 16, this is 4, that would be 44, right? 44 minus 4. So for the amount of work that I have to think about this is all I have to do here is add, multiply. Okay, so that's what this remainder theorem is about, which is kind of neat because it does matter. Sometimes it's easier to do it one way versus the other. Okay, all right, so f of negative 6. Do you want to plug negative 6 in here and work it out? Go right ahead. I'm just going to do negative 6, and I'm going to put these same numbers back, and I'm going to bring down that 2, and I'm going to do synthetic division. So 2 times negative 6 is negative 12. I'm going to add that column, get negative 1, multiply negative 1 times negative 6, that's positive 6. Add that column, I get negative 1. Negative 6 times negative 1, positive 6, I get a remainder of 0. So that means f of negative 6 is 0. So again, if I put in negative 6 into here, 2 times negative 6 cubed plus 11 times negative 6 squared minus 7 times negative 6 minus 6. If I do that, I will get 0. Okay? So that's kind of neat. It works either way. So the function, that's what that says. The function value is the same as the remainder. Okay? F of c is the remainder, function value. All right, so look at number 8. This is a good instance where this would be beneficial to know you can do it either way. So use the remainder theorem to show that square root of 5 is a 0. Well, I don't really want to put the square root of 5 in here and multiply. That would be really hard for anybody to do. That's not a nice whole number that we can work with easy. So in this case, I would choose to do this method. Okay, so I would do square root of 5 cubed minus 4 square root of 5 squared. So I'm putting the square root of 5 in here, minus 5 square root of 5 plus 20. Still got to have radicals, but to me this is a little bit easier. So if I cube the square root of 5, I get 5 square root of 5. If I square the square root of 5, that's 5 times 4, that's 20. This can't do anything, and that's plus 20. So now I've got 5 square root of 5 minus 5 square root of 5. That cancels out. Negative 20 plus 20, that cancels out. Guess what? I get 0. So it said, use the remainder theorem to show that it's a 0. If the remainder is 0, then x minus c is a factor. Okay? So it is a 0, we got 0. Okay? All right. So let's look at the next theorem, which is called the factor theorem. Very similar. Let f of x be the polynomial function, then x minus c is a factor of f of x if and only if f of c equals 0. So that's what we just kind of did on the last problem. So if f of c equals 0, then x minus c is a factor. If x minus c is a factor, then f of c is 0. So they go hand in hand. So if you know one thing, you know the other. All right, so determine if the following are factors of this polynomial. Use the factor theorem. So is x minus 4 a factor? Okay, so I'm going to do them one each way so you can see. You can pick whichever way you'd like to do it. So let's do x minus 4, okay, using the synthetic division, seeing if we get 0 as the remainder. So we're going to put 4 in the box. We've got our polynomial, so we're going to do 1, 6, negative 7, negative 60. We're going to bring down that first term. So if this is a factor, we will get a remainder of 0. Okay? So 1 times 4 is 4. That's 10. 10 times 4 is 40. That is 33. 33 times 4 is 132. And we're definitely not going to get 0 as our remainder, right? This is not. I don't even care what it is, but it's not 0. So this is not a factor. Okay? It did not get 0 here. Now, the other way I could do it is to look at the function value. So, is this a factor? Well, again, if I'm using x plus 5 as the factor and I set it equal to 0, then I'm actually looking at f of negative 5, right? Negative 5 would be the number that I would put in the box. Okay, so if I put negative 5 in here, negative 5 cubed plus 6 times negative 5 squared minus 7 times negative 5 minus 60. Okay, I'm just going to stick this in the calculator. Put it here so you guys can see. So we're going to do negative 5 cubed plus 6 times, I'm just going to make that 25, right? Negative 5 squared is a positive 25 minus, this will be positive 35 and then minus 60. I'm just doing a little bit in my head. So I ended up with 0. So I got that equals 0. So this, yes, is a factor, okay, because my function value is 0. So again, if I put negative 5 in here and worked it out, I would got 0 as the remainder. So the factor theorem basically is telling you that you want to find it this way. The remainder theorem says the same thing. So this is more remainder theorem, this is more factor theorem. But honestly, whichever way you feel more comfortable doing is perfectly fine, because they're both helping you do the same thing to determine whether or not remainders are 0, which would tell you whether or not that number is a factor. Okay? So you can pick. Either way is fine. All right, look at number 10. Factor f of x. So we're going to factor this given that x minus 2 is a factor. So here's a case where I definitely want to use one over the other. So take a look at this. If we want to factor this, and it's x cubed, I'm going to get three things that look like this, right? X plus this, x minus, whatever the factors are. So I don't necessarily want to do this because all this is going to do is give me the remainder. What I need to do is this because I'm going to need these numbers to write the new polynomial down, okay? Because I need to be able to factor. So I'm going to do synthetic division. I'm going to put 2 in the box. Remember, if x minus 2 is a factor and you set it equal to 0, you get 2. That's the number that goes in the box. And I'm going to write my coefficients, 2, 3, negative 29, 30. Now here's the difference with this problem. Put that down. This is telling us that x minus 2 is a factor. So I know I'm going to get 0 here. I know that right now. So if I don't, I've done something wrong. But the thing is, because I have to factor this, I have to get these numbers. That's how I'm going to get the rest of the polynomial to factor. Okay? All right, so let's hope we get 0. So 2 times 2 is 4. We're going to add that. 7 times 2 is 14. We're going to add that. 2 times negative 15. And we're going to add that. So we did get that. So now here's the coefficients of what's left, the polynomial of the quotient, right? So we're going to start 1 degree less than 3. So 2x squared plus 7x minus 15 is the next polynomial. So remember, I already know that one of the factors is x minus 2. So now all I have to do is factor this, which I can do. This was kind of hard to do on our own, but this we can easily factor into 2 more binomials. So we're going to factor that, figure out what our other 2 factors are, okay? So factors of 2 in the first place has to be 2x and x, and then we just need to figure out how to get 15 when we multiply here, but we also got to get 7 in the middle, right? So we're going to use 5 here, because that's 10, and the 3 here, because that's 3. So 10 minus 3 will give us the 7. And I need 10 to be positive and the 3 to be negative to give me a negative 15 and a positive 7. Remember, once you try out your combination, FOIL it out and make sure that works, okay? And then you have your other factor over here that they gave us. So there's the factors. Didn't take too much work, but there's the factors of that, okay? All right, so now it says to solve this equation. Same equation. Well, once I have the factors, I just set each factor equal to 0, and I'll get my answers. All right, so set each of those factors from above. Set this equal to 0, this equal to 0, that equal to 0. So this first one, I'll get 2x equals 3, so x is 3/2. This I'll get negative 5, and the last one I'll get positive 2. So there are my solutions, okay, to the same polynomial. So again, factors look like that. These are the solutions, or the zeros, okay? They always go together. It's opposite signs. Okay. So the last thing you have to do in this section is to construct a polynomial given some information, okay? All right, so this time they're giving you the zeros, and they're giving you something about the end behavior. All right, so let's look at this over here. I'm going to draw a little, forget about this numbers right now. It says, and goes to negative infinity as x goes to negative infinity. Well, if x is going negative infinity, x is going this way, and this is y. So if y is going to negative infinity, that would be this way. So that means the left side is going down, okay? Now, if it's a second degree equation, remember both sides have to do the same thing. So that means the right side would also have to be down, which means the a value has to be a negative number, right? Remember, your leading term has to be negative. All right, so second degree, if these are the zeros, remember how to find the factor. So x equals negative 2 is a 0, and x equals 6 is a 0. So now we want this side to be 0. So we're going to move the negative 2 back over here. So that would be x plus 2. We'd move the 6 over to the left. That would be minus. So these are the factors. Look at the signs. The signs are always opposite. That's how you get it if you want to go backwards. A lot of you will just know if negative 2 is the 0, then x plus 2 is the factor. I mean, that would be good to know that really quickly. But that's why that's true. Okay? We're going in the reverse order now. All right, so we're going to find this polynomial. So now we're going to multiply our factors together. Except if I multiply x times x, I'm going to get a positive x squared. And I need the leading coefficient to be negative. So I just want to put maybe a negative sign here. And that will change everything up at the end because I need that leading term to be a negative number. Okay, so let's FOIL that out. So first is x times x, x squared. Outer is negative 6x, and inner is 2x, so that's a negative 4x. And then last, 2 times negative 6 is negative 12. And then we're going to change the sign. So negative x squared plus 4x plus 12. And then it said to construct a function, so I'm just going to stick f of x in front of here. So there's a function whose left side will be going down, and the factors would be x plus 2 and x minus 6, so the roots would, or the solutions would be negative 2 and positive 6. Okay? All right, so we're going to do the same thing with a third degree polynomial. So they're giving us 3 zeros. So again, opposite signs. So if negative 1 is the 0, then x plus 1 is the factor. If 3 is the 0, x minus 3 is the factor. If negative 3 is the 0, x plus 3, right? Always the opposite sign. So I know I got to multiply all this out. Now I got to talk about the leading term. So this one says we're going to go to positive infinity as x goes to positive infinity. So as x goes this way, y is going this way. This is a third degree equation. So if the right side's up, the left side has to be down. That means the leading coefficient would be positive. Right side up means your leading coefficient is positive, so I don't have to add anything to this. This will be fine the way that it is. Okay? All right. So I'm going to go ahead and multiply the last two. That seems easier because that's a difference of squares. So let's leave x plus 1. FOIL these two out. So x times x is x squared. The outer is 3x and the inner is negative 3x, so they're going to go away, cancel out. And then you just have to do negative 3 times positive 3, which is minus 9. So this one is much easier to multiply. That's why I chose to do those two first. You could have done these two, would have been the same answer. All right, so now I got another binomial times a binomial. Okay, so I'm going to write f of x equals, because I think we'll get the answer as soon as we FOIL this out. So x times x squared is x cubed. Okay, outer is negative 9x. The inner is 1 times x squared, which is just x squared. And last would be 1 times negative 9. And that's fine, except it's not really in standard form. So let's rearrange our exponents so that they are in descending order. I would not take off for this, but I don't know, again, in Hawks, you might have to put them in the right order, okay? All right, so that does it for this section. So now you've got all your information to work on your homework, and just let me know if you have any questions, okay?